Okay, I need to say one thing before I start this. I kind of forgot that the PSAT is Monday morning from first through third period. So that means all juniors are going to be taking the PSAT, and I'm going to be giving it. So my seniors and sophomores need to go to Miss Bledsoe's. She is down the hall, at the very end of the hall. So I'm on my side of the hall. This is me, and then this is her down here. Okay, so you have to go down here, first and second period, just on Monday. Okay, so let's go ahead and, oh, well, that means that moves the test to Wednesday, because Tuesday we'll have to go over the review for the 9 weeks test, and then Wednesday take it. Okay, so what we want to do is we want to go through this point and be parallel to this line. Well, to be parallel means you have the same slope, and that's the only thing you have the same. Well, the slope of this line is -7/3. So I know that's the slope I need for my new line. So y equals mx plus b. It does say just write the equation, so I could write it in mx plus b and find b, but I don't have to. If I just remember y minus y1 equals m times x minus x1, then I could be done. Y minus the y value at this point, 5, equals m, which is a -7/3, x minus the x value, which is a -3, which makes that a +3. Okay? Or, and I could be done, just leave it like that. Or I could say, okay, if I don't remember that formula, then surely you remember y equals mx plus b. Y is 5, m is -7/3, x is -3, plus b. A -7 divided by 3 times a -3. Well, the negative times the negative is a positive. 3 divided by 3 is gone. So 5 equals 7 plus b. b equals 5 minus 7, which is a -2. So then you could say y equals m, -7/3 x, minus 2. So this equation or this equation, either one would work as an answer. Okay? In the other version, you have through this point and parallel to this, which means your slope is -9/2. Okay? So y equals mx plus b, or y minus y1 equals m times x minus x1. So y is -5, m is -9/2, x is 2, and then b. 2's cancel out, and then I'm going to add 9. So then 4 is b. Y equals a -9/2 x plus 4. There's my equation. Or y minus y1, a -5, so plus 5, equals m, a -9/2, times x minus x1, which is 2. And there we go. So either one of these is acceptable. Okay, now let's talk about number 3. If you need to go through this point and be perpendicular to this line, well, to be perpendicular means you meet at a 90-degree angle, and your slopes are exactly opposite. So this slope would be +1, whereas this slope would be -1. So if my slope is, say, 2/3, then the perpendicular to that would be a -3/2. Okay? If my slope is a -5/7, then perpendicular to that would be a +7/5. So you change the sign and you flip the fraction. Okay, well, perpendicular to this would mean my slope is a +4/3. Okay, it says slope-intercept form, so y equals mx plus b. Y equals mx plus b. Y is the 2, m is the 4/3, x is the 3, plus b. 3's cancel out. 2 equals 4 plus b, minus 4. b equals a -2. Okay? Well, if b equals a -2, then I can say y equals 4/3 x minus 2. Now, if I want to do it the other way, y minus y1, 2, equals m, 4/3 times x minus x1. And then distribute. 4/3 times x is 4/3 x. 4/3 times -3 is a 4/3 times a negative 3. 3's cancel out, and I've got a negative 1 times 4, which is a negative 4. Y minus 2, so if I add 2 to both sides, then y equals 4/3 x minus 2. Either way, you get the same thing. Okay? So on this one, on version 1, perpendicular to negative 5/2 would be a positive 2/5. So y equals mx plus b. That's your y, that's your m, that's your x, and then I gotta find b. A negative 5 divided by a positive 5 is a negative 1. 2 times a negative 1 is negative 2. Add 2 to both sides, and you get b is 3. So y equals m x plus b. Okay? Or like the other one, y minus y1 equals m times x minus x1. Okay? Distribute and simplify. Okay, now let's talk about number 4. If y varies directly with x, and y equals 21 when x equals 6, that should be a comma, and that should be a lowercase. What is the constant of variation? Well, direct variation, when something varies directly with another, that means that y can be written as some constant times x. Or the constant can be written as, well, if you divide by x, you get y over x. So the constant is y divided by x. So when it says, what is the constant of variation? Well, the constant of variation, k, is y divided by x. So 21 divided by 6, which is 7/2. 21 divided by 6. So 21 divided by 6 is 3.5, or 7/2, okay? So when they ask, find the value of y when x is 12, well, there's a couple different ways to do that. One is to say, well, y equals k times x. So they're saying k is 3.5, x is 12. What is y? Well, 12 times 3.5 is 42. So then I could say y is 42. Another way to do that is just to do a proportion. Y is to x as y is to x. If there's a constant, if they vary constantly, then, or directly, then this proportion should hold true. So if 21 is to 6, then what is y when x is 12? Okay, well then all you gotta do is cross multiply, or just multiply both sides by 12 if you think of it like that. 12's cancel out over here. 12 times 21 divided by 6. 12 times 21 divided by 6 is 42. Okay, y is 42. So same thing on this one. Okay, y is 18 when x is 6, so 18 divided by 6 is k, because k is y divided by x, which we get from y equals k times x, which is 3. Okay, so a couple different ways. Y equals 3x. If x is 10, then y is 30. Or 18 is to 6 as y is to 10. Multiply by 10, and you get 180 divided by 6, which is 30. Okay, last one. If you're doing this one, the first thing you need to recognize is that this is a set of data, and that we're going to have to use the calculator, okay? It says, create a scatter plot and let x equal the number of years since 2000. Well, if that is the number of years since 2000, that means that this is year, if 2000 is year 0, then that means this is year 1, 2, 3, 4, 5, and 6, okay? Now, if you use the years, it just makes your function a whole lot uglier, and I'd rather you use this. I said let x equal the number of years since 2000. So this has been 1 year since 2000, 2 years since 2000. So I've got some space in here. I'm going to let this be 1, 2, 3, 4, 5, and 6. Okay, so this is years since 2000. Okay, Well, then what we got is we've got prices of boxes of oranges. So they only go from $6 to 8.5. Well, less than 8.5. So I'm gonna do a break and start at $6, and then do every. Doesn't really matter. I could just do 25 cents. So $6.50, $7, $7.50, $8, $8.50. And so this is price per box. Okay. So now what I want to do is I want to plot those data points, which in general no one had issues with, but at the same time, a few of us put the X and the Y mixed up, and then you didn't label. You got to do some things, okay? So at 1 we're at $6.04. At 2 we're at $6.55. That's 75. So 3 we're at $7. 4 we're at $6.80. So that's $6.75. So 80 somewhere in here. 5 we're at $7.80. So 5 we're at $7.80. So that's $7.75, $7.80. And we're at $8.30. So $8.25, so 30. Oop, Okay, so there we go. Now, what I can see is that this is going to be a pretty good fit. The data is pretty strong that it's going to be linear. Okay, now that part's done. It says calculate and identify the line of best fit. Guys, a lot of you did not put the line here. It says the line of best fit. And we went over, you need to find it using your calculator. So I'm going to go to stat. So I'm going to go to stat. I'm going to go to edit. And I'm going to enter my data. 1, 2, 3, 4, 5, 6. Then I'm going to enter my prices. So 6.04, 6.55, $7, 6.80, 7.80, and 8.30. Okay. Now what I want to do is I want to calculate my line of best fit. So then I'm going to go to stat, back to stat. I'm going to go over to calculate. And I'm going to go to number 4. Linear regression. So I press enter. Now, I will grab another calculator. If you end up with a screen like this, then all you have to do is remember that you want to put this in y equals. So you go alpha trace y1, press enter, and you get this. Now, if I don't get my R, then I know that my stat diagnostics are not on. So I'm going to go to mode. I'm going to go up to stat diagnostics, select on, so I can quit. I'm going to go back to stat, calculate, number 4, alpha trace, and press enter, and I get it, okay? So here's what I've got. Y equals AX plus B, where A is this and B is that. I think a lot of you did this, but then you didn't actually write this down. You've got to write this down. This is the line. So what I've got to do is I've got to say Y equals A.424X plus B 5.597. Okay? So there's my line of best fit. It says state the correlation coefficient and describe the relationship. I have never talked about R squared, so do not write down R squared. It's R. It's the bottom one. R equals 0.955, and it says describe the relationship. Well, some of you said, well, that's a strong fit, and that's what I want to see. Some of you said, well, that's 95.5% fit. Good. Okay, that means it's a strong correlation between the years and the price of the oranges, okay? And then this last thing says, predict the price for 2015. Okay, if I predict the price for 2015, then what I have to say is, okay, if 2000 is year 0, then 2015 is year 15. And I have to do that because I put my numbers, my years in just single-digit numbers. So what I'm going to do is two different things. One of them is just say, well, if x is, see, x are the years. If x equals 15, then what does y equal? So 0.424 times 15 plus 5.597, and I get $11.95 or 96 cents, whichever one you want to say. The other option is, because I did the alpha trace, and if you forget the alpha trace, that's fine, because you can always do this. But if you do the alpha trace, then you can go to second table and look up the y value when x equals 15. And there you go, $11, and according to this, 96 cents. So I would accept either. Okay. So now let's do it on this one. Okay. I'm going to use this one just so you can see the difference screen, just in case you run into that. I'm not going to plot the data again. It's the same type of thing as that, just the numbers are a little bit different. The years since 2000, again, this is 1, 2, 3, 4, 5, and 6. So I'm going to go stat, edit. Okay. 1, 2, 3, 4, 5, and 6. $6.05, $6.75, $7.05, $6.90, $7.90, $8.40. Okay, so I'm going to go stat, calculate, number 4. Okay, so we entered our data under stat, edit. Now we're going to go to calculate the line of best fit. So stat, calculate, number 4. Now list 1, list 2. I don't care about frequency list, but if I want to store my equation, then I go to alpha trace y1, press enter, and it gives me this. Now again, I don't have that, so I'm going to go to mode, up to stat diagnostics, press on. Now if I just press second quit, and then if I press second entry, it'll do the same last thing I just did. Now it looks different, but that's okay. Press enter, and there you go. Okay. So what is my line of best fit? Well, my line of best fit is y equals a, which is 0.43, x plus b, which is 5.67. Okay, just kidding. There's my line of best fit. Okay, state the correlation coefficient. The correlation coefficient is R. R equals 0.953, which is a 95.3% fit, or you could say it's a strong correlation, strong fit, strong relationship between the data. Predict the price for 2015. Again, if 2000 is 0 for x, then 2015 means x equals 15. So I could say 0.43 times 15 plus 5.67 is y. So 0.43 times 15 plus 5.67, and I get $12.12. Or I can go to my table, look up 15. I evidently have something else on Y too. And I get that $12.12. Okay? I hope that this helps, and I hope that you study it. Come in early if you need any help, or just let me know. Email me or message me on Sunday. Okay.